Hello, so today we'll be discussing Ohm's law measurement. As we can see, V equals to IR, which is our volts, and I represent our current, and R is our resistance. As we can see, this represents the relationship between the voltage and the current and the resistance, as we can see in the Ohm's law triangle. So we'll be making use of this circuit diagram to explain the Ohm's law calculation and measurement. So we'll be making use of a DC voltage source, as we can see, a DC voltage source with then our breadboard, which is connected to the DC voltage source. So we'll be making use of multimeters, digital multimeters. In this case, from our diagram, we can see that we'll be needing two, so we're making use of two multimeters. So we have the bigger one, which is a bigger multimeter should be used for the current measurement preferably, while the smaller one can be used for the voltage measurements. So next, the first thing we do, as you can see, our jumper wires have been used to connect our voltage source to our breadboard. So the next thing, we have our resistor, which will be used for the experiments from our circuit diagram. This is a 1.5k ohms resistor, but always measure your resistor's resistance apart from the calculated one using the color codes. So you adjust the range of your multimeters and put it in the ohms range. You plug in your probes, then you take measurement of your resistor. So you put your probes across the terminals and measure the resistance of your resistor. And as you can see, we have 1.743. Make sure you get it, 1.74k ohms. Now this is possible because of the tolerance. This is a resistor that has a high tolerance. So it's a 1.5k ohms, but the tolerance allows it to go further more, which is why we have 1.745 resistor. So we plug in our voltage source. We measure our input voltage. So the jumper wires have been made to create a connection between the voltage source and the breadboard. So you take measurement of your voltage source to adjust your multimeters to the DC voltage range, and because this is a 15, so you can adjust it to the 20 range. Then you measure your input voltage. Make sure your jumper wires, you peel it to the conducting part. So our input voltage from our measurement, you can see is 15.56 volts, and our breadboards are, as you can see, these are connected together, and these are connected in series. So these are connected in parallel. There's a break in between, and these are connected in series. So going by our our circuit diagram, so we plug in, fixing our resistor. So one terminal goes to the positive of the source and the second goes to the negative. Now, and we take our current measurements, we break the circuit. So this is very important part when taking current measurements. So we break before taking our measurements, we do that. So we can as well leave the negative out, but you can put it on the breadboard just to make your. So as you can see, the voltage flows into the resistor. Then we take the current measurement at the output. So that's how you measure current. Current is always measured at the output. So you take your probes, put one of the probe on the terminal of the resistor and one of them on the terminal of the voltage source, the negative voltage source, as we can see. So that's how current flows into a circuit, a resistor preferably. So we make use of our big multimeter as stated before. This is very important as current measurements are being measured with a bigger digital multimeter with a bigger range, which are smaller digital multimeters wouldn't measure. So you bring your comb into your comb, then you change you put your red probe, which is into the ampere area. So you put it in there. You see, already adjusted the multimeter to the ammeter's range. Then you take your measurements. So as we can see, measuring the current at the output gives us 0.009 amperes. Just you can put it in the milliamperes just to be sure. Current flowing, as you can see, still the same. So how do you prove this? How do you know this is correct? According to Ohm's law, if you do the calculations, as you can see, we are correct from our calculations. So you can as well try other resistors. So we're going to make use of another resistor. Remember, always take measurement of your resistance apart from the calculated value. So we're going to be using a 1K resistor. So you adjust your range and put it in the resistance range. Then you take your measurement. So we have 0.98. So that is approximately a 1K ohm resistor. So doing the same thing, we fix it across our breadboard. So we measure at the output like we did before. Switch on your voltage. So always switch it off and switch it on to avoid electric shock. In case you are working with a more complex and higher voltage source. So you set your multimeter to the range, milliampere or ampere, and you take your measurements. So follow the convention. As you can see, negative connected to negative and positive connected to positive. We have 0.015 ampere. As you can see, these are current. If you go by calculation, that will be okay. Moving on, we try another resistor again. Now we're going to be working with a 3.3 kilo ohms resistor. Make sure to do the measurements of the resistance. As you can see from we have 3.2 kilo ohms to work with now. So you take your measurements. This is just a way for you to learn and just to see a pattern, which we are going to discuss at the end. So we are working with a 3.2 kilo ohm resistor now. So fix it gently. So current flows in and you take your measurement at the output as we have been doing before. So you take our measurements now at the output, and as we can see, okay, make sure to on your voltage source current. So you have 0.05 ampere, and as we can as well notice, the higher the resistance, the lower the watts, the lower the current, and Ohm's law is proved. Thank you.